Which of the following statement is false for a binomial distribution? Remember this, when we say binomial distribution, we say it's binomial distribution. We write it this way, like B and P. So it means like we are doing n experiments, and each experiment has two outcomes, possible outcomes. So it means, and we two outcomes, like outcome, the first outcome is success, and the second outcome is like the failure. We generally say it this way. It will change, you know, depending on the experiment. It might be like head or tail, or tail or head. I mean, it depends on what what's your success. I mean, which one do you accept success? Like boy or girl, you want boy or you want girl, for example, choosing from the children. Or, you know, always two outcomes here. There will be two outcomes, always two outcomes. And the success, the probability of success for each experiment is fixed. So it's P. Now, and each experiment here, or the experiment or trial, we can say they're all independent. So which one is false for a binomial distribution? We're assuming sampling without replacement. No, this is not the case, because when we do the experiments here, the first one, the second one, and the third one, so they're all independent here. So they're independently. So when you're tossing a coin, for example, a coin like n times, so like these are independent. And if you do the sampling without replacement, it will be not independent, so it will be A. So only possible two outcomes for each trial. Yes, has two possible outcomes, you know, and this is true. And the random variable is discrete. Yes, each trial is independent. Yes, so it will be A. Now, suppose 20 donors came to a blood drive. Assume that the blood donors are not related in any way, so that we can consider them independent. The probability of that the donor is zero blood is 0.06, which is constant from donor to donor. Let X be the number of the donors that have zero blood. What is the distribution of X? So you pick 20 people. So you pick 20 people. So it goes like this. First person, you have two options: zero blood, zero, or not zero. Second one, second person, like zero or not zero. So you have two outcomes here, as you see each. So you can think of this one like experiment here. The first one, tossing a coin, for example, it's like tossing a coin. Like these persons, like each toss, okay? So it goes up to 20. So it goes up to 20 here. So the X is the number of donors. The zero blood is our success here. Okay, what is the distribution of X? So it's like this one is, this distribution is like you toss the coin, like toss a coin 20 times. You got each time like the coin is like head or tail. Head. The second toss, you know, the first toss, it'll be like head or tail. The second toss, the second one, head, tail. You know, it's something like this. So they are they are both binomial distribution here, binomial distribution. So your success is here, the success. What is success here? Success here is defined by X. So success here is having zero blood. 0 blood. So it has to be a binomial distribution. And how many experiments are there? I mean, we have 20 people, so it will be 20. And having a 0 blood is the success, you know, the binomial expression here, the binomial. We have this one here, the number of trials. In this case, in our case, it will be 20 people, choosing 20 people. I mean, we have 20 people and choosing from there. And our probability of the success, the probability of success. So the probability of success, it means like 0 blood. The probability of choosing 0 blood is, what is it? This is 0.06. So it has to be A. Suppose we have a random variable x where pxk is equal to 15 choose k 0.29k to the k power 0.71 to the 15 minus k for k 0.1 15. What is the mean of x? So the probability function, the probability function px equal to k has this formula, okay? Has this formula. If x has binomial distribution, and here where the number of trials will be at most, okay, we have how many trials? We have 16. Okay, 16 trials. Sorry, this is 15. Sorry, this is 15. So we will have 15 trials here. 15 trials. Okay, and here, I mean, you can look at here, of course. I mean, you can look at here. It's 15. And what is the probability of success here is 0. So you look at here kate power, it will be 0.29. So you have to say here 0.29. So this random variable x has a binomial distribution because how can we tell it? From the probability function. Now, what is the mean? Okay, if x has, okay, remember this. Okay, this is, remember, if x has a binomial distribution like this, the mean of x is n times p. So what you can do here, like you multiply, the mean now will be equal to 15 times 0.29, and which will be something like 4.35. So you have to know this function. If the probability function is this, then you can say it's a binomial distribution, and you can say there are 15 trials and like 0.29 is the success probability. And then you can say here, you can use this information now. If we have a binomial distribution, then the mean of x is n times p. N is this and p is this, so you know n times p is like 4.35. Now x has a binomial distribution with 20 trials, a mean of 5. The success probability is what? So if x has a binomial distribution with 20 trials and with success probability p, what is p? Okay, so what is given? It says like binomial distribution with 20 trials. We don't know p, but the mean is 5. So the mean here, it says the mean of x is 5. So remember again, if x is binomial np, then the mean of x is equal to n times p. So this has to be, the mean of x should be 20 times p, which is equal to 5. and the p turns out to be 0.25. So you solve this one like p is equal to 5 over 20, so then it will be 0.25. Now a die is rolled 72 times. Find the mean standard deviation of the number of 2 that will be rolled. Okay. Now the first thing is we have to figure out what is this distribution like this. Every every probability question, the random variable has a probability distribution function, and what is this distribution? We have to figure this out. So a die is rolled 72 times. So we are doing an experiment, like we have 72 trials. So 72, we are rolling it 72 times. So it means like we have 72 experiments, or we can say 72 trials. Okay, and what is our X? So success. Success will be having number 2. Okay, X is the number, so the number of the times that we roll 2, okay, in the dice. So here, so the question now, it's this is X, it will be a binomial distribution. How? Because when you roll the die, so you will get something like this. The first roll, the first trial, or the first roll, we can say roll, we will have this. We will have 2, not 2. In the second trial, we will have 2 or not 2. It will go like this. So the success here, the success here is having or getting 2. So what is the probability of success for one single die? So the probability of success means like the probability of getting 2 when a dice is rolled. So what is the probability of getting, like this is 2 out of 2 is just one number out of 6. So there are 6 numbers and one of them is 2. So the probability of getting 2 is like 1 over 6. So the probability of success here, success, so it means like getting 2 in each trial, getting 2 in each trial is 1 over 6. So okay, I want to keep this one here. Okay, this was just to find the probability of success. Now what is the okay, now X, look at this experiment here. It will go like this. So we have 2 outcomes here, and each time like we will have 1 over 6 probability here getting 2, and 5 over 6 probability getting that 2, and we have 72 trials. So this is a binomial distribution now. So we are doing an experiment, or the trials that have each time they're independent of each other, they do not affect each other, and they have a binomial distribution. So we can say the binomial distribution, 72 experiments with success probability 1 over 6. Now the first thing is this. Then we can do the rest now. To answer the question here, the mean and the standard deviation, we don't have to calculate them. We have some formulas for them. So this is an important fact. So we have to remember this. If X is binomial, it has binomial distribution with NP and trials with success probability P, then the mean will be equal to, the mean of X is this, N times P, and the standard deviation of X, okay, my writing is not good. N times P times 1 minus P, take square root. So what is n here? So the mean here will be 72 times 1 over 6, which will be 72. So it's 12. So you can say 12 here and then 12 here. And then next thing is like the standard deviation of x. So it'll be 72 times, okay, n times p times 1 minus p, which is like 1 minus 1 over 6. Then take the square root of it. So this will give you 72. I don't have calculator, but anyway, I will try to. Wait, like, okay, this will be like something like square root 10. So it has to be square root 10. Okay, in this question, first, you have to know it's a binomial distribution. Okay, then you have to find the probability of success. Okay, and now you have to use these two facts here, the mean and standard deviation of a binomial distribution. So these are the important information here. Now compute the probability of x successes, x equal to 5 successes using the binomial formula, and then n, the number of trials, and the probability of the success is this. So here, x has the binomial distribution. Okay, binomial distribution like 10, 0.73. And the probability of getting x equal to k, the formula is this. You have to say like n choose k, which is 10 choose k. K is what? Okay, first I will write here the general formula here, sorry. N, okay, I'll write the formula here. N, this is p. Let's say the n choose k, and then times p2 k power times 1 minus p 2 n minus k power. So then you can use this one. Now p x equal to 5 is equal to c 10 and choose, okay, 10 choose 5, p to the k, p is here 0.73, then 1 minus 0.73, like 10 minus 0.73, 10 minus k, sorry, this will be 5 here, and then this will be 5 here, so it will be 10, 5, 0.73 to the fifth times 0.27 to the fifth. You can use your calculator and find it. Okay, I don't have calculator with me right now. Okay, let's look at this problem here. Approximately 10.3% of American high school students drop out of school before graduation. So they left the school, they don't want to graduate. So it says the students, like 10% of the students drop out of school. It means they left the school, they don't want to graduate. Choose 10 students entering a high school at random. Find the probability that no more than 2 drop out. Here, when you choose a student here, when you choose a student, you have 2 possibilities for them. You will drop out or won't drop out. So when you choose a student, like your students are your trials here, and then there are 2 outcomes, will drop out or not. So you can say choose the first student, you have this option here for a student, and the second student, like if you choose the second one, then we have the 2 outcomes again, will drop out and won't drop out. So this is, as you see here, if you say these are the trials here, then this will give you a binomial distribution. So okay, the probability of dropout here the probability of dropout is what? So it says like 10% of the American high school students drop out. So it means 10.3% is the probability of dropping out. So the probability of dropping out is 10.3 over 100. So this is the probability of dropout. So it says the probability that no more than 2 drop out. So the X, the number of students who will drop out. So this X, okay, if you choose, okay, the X is the random variable. I mean, X is the variable, the random variable with the binomial distribution. And here we have how many, okay, how many students we choose. We choose 10 students, so we have 10 trials here. And our success is dropout. Success is drop out. So what's the probability dropout here? This probability of success here is 10.3%, so it means like 0.103. So basically we set up the X here. The X is the binomial distribution. Now how can you calculate the probability that the X is no more than 2? So X is no more than 2 means X is less than or equal to 2. So we want to calculate this. So no more than 2 means like no one will drop out, or 1 will drop out, or 2 will drop out. So how can you, okay, if this is the binomial distribution, how can you calculate the probability of X equal to K? So we have a formula for it. It will be n choose like 10 choose K. We call it 10 choose K, and then 0.103 to the K power times 1 minus 0.103 to 10 minus K power. So by using this formula, we will calculate. Now we have to calculate. Okay, we can calculate these then with this formula here. Put 0 here, put 0, and you got here C 10 0, and 10 choose 0, and then 0.103 0 power times this will be 1 minus 108, 103 is like 800, 0.897. Okay, then this will be like 10 minus 0, which is 10. So then we will calculate this one here, p x equal to 1. So what is this? So you have to put here 1. So you put here c sub n choose 1, and a 0.103 to the first power times the 0.897 times, I mean 7 to the 10 minus 1, which is, okay, if you put here k equal to 1, so you get 9. And then 10 choose for x equal to 2. We are doing it for 2. Then choose k 0.103, and then 2, and this is 0.897, and then this will be 8 power. You know, this is 10 minus 2. This will be 8. So you can calculate the n choose k, or 10 0. I mean 10 choose 0. This is the combination. 0 combinations of 10, the number of 0 combinations of 10. This means like the 1 combinations of 10, or we choose how many times, how many different ways can we choose one element from 10, and this is like how many in how many ways can we calculate, can we choose 2 elements from 10 elements. So this is, you can do it with the calculator, I think. Yeah, you can use calculator, and when you calculate this one, you will get the probability here. I don't know this one. You can use your calculator and find it. Question 4. A lab network consisting of 5 computers was attacked by a computer virus. This virus enters each computer with probability of 0.4 independently of other computers. So we have 5 computers here. So each computer can be attacked by a virus. Okay, so we can say with virus, I mean viruses with virus and without virus. So there are 2 possibilities for each. Has a virus, has the virus, or let's say infected. Okay, infected by the virus and not infected by the virus. So infected, so not infected. So each time for each computer, I mean for each computer, we have these possible outcomes like infected or not infected. So each time we have these two, like head and tail, like when you toss the coins, we have head and tail. It's the same thing. So here we can think them like each computer is like the one trial, and then it's like the second trial. So it goes like this. You can think of them this way. So getting infected here is this. The probability of getting infected here is 0.4. Now getting not infected is like 1 minus 0.4, which is like 0.6. Now this is a binomial distribution here. This, okay, what is x, by the way? So we have to talk about the x. So we say let x be the number of computers that has that have been infected by the virus. Okay, now x is a random variable with this binomial distribution here. The binomial distribution here is how many trials we have, up to 5 computers. We have 5 trials, and the success, the probability of success is what? So success here is getting infected. You know, you can define the success as the not infected, but in this case you have to calculate the probabilities like depending on your success. Okay, so you have to consider your success. I mean, you can always like you choose the success to the other one, and you can calculate you can answer the questions this way, but you have to modify your calculation then a little bit maybe. Okay, success, let's say the getting infected is success 0.4. Why? Because we already defined the x also infected. So infection is like getting infected is the success here. So what's the probability of success? It's 0.4. Now we know the probability of k computers getting affected is by this binomial distribution. It has to be like 5 choose k and times 0.4 to the k power, and then like 1 minus 0.4 to the 5 minus k. So we will use this probability function for this. So probability that the virus exactly enters exactly 3 computers. So it means like only 3 computers are infected. So it means like it's asking the probability of x equal to 3, exactly 3. So it has to be, okay, by using this formula here now, we can use the formula here. The formula will tell us 5 choose 3. Okay, you can calculate it with your calculator, by the way. 0.4 to the k power. The k power is 3 here. And then 1 minus 0.4, which is 0.6. And then 5 minus 3. So then you can calculate this one. What is the probability that the virus, okay, now calculate. I'm saying just calculate by a calculator. Now find the probability that the virus enters at least one computer. So at least means the number of infected computers will be more than one, or more, equal to or more than one. So what does this mean here? It means we have to calculate px equal to 2, px equal to 3, px equal to 4, and px equal to 5. Okay, now I will erase here. So I just wanted to tell you this is a binomial distribution. So if you know something is like a variable is random variables as binomial distribution, so then it has a certain formula of calculating the probability. So we use it here. And then px5. Using this formula here will take a big time. Each time we have to calculate, and it will take a time. So for this reason, since this is a discrete probability function, in the probability distribution, in a discrete probability function, in a discrete probability distribution, the fact is, like, when you put all the possible outcomes here, like the numbers 0 up to 5, that will be none of them affected or all of them affected, and all the possibilities here, all the possible probabilities will be equal to 1. So I'm using this one now. So in a probability distribution, the discrete probability distribution, all the probabilities sum up to 1. Okay, so then you can write here as 1 minus px equal to 0, and then minus px equal to 1. And then you can calculate these two only with the calculator and subtract from 1 then. So instead of calculating each of them, you can do this shortcut. So it will be like 1 minus 5 choose 0, 0.5 to the 0th power, then 0.6 to the 5th power, then minus c, like this one is like 5c 1, or 5 choose 1, 0.4 to the 1st power, then 0.6 to the 4th power. This I'm using this one and this one here. Okay, so you can calculate these, and you can subtract from 1. This will be the solution. Now, what is the mean variance and the standard deviation of this variable x? So the question should be asked this way. But anyway, okay, we know this is the variable and it's asking the mean of x, mean of the infected computers indeed. This is, okay, I want to remind you this one now. Okay, I'll write a reminder here so you can check it from the lecture slide also, if this is binomial and p, and this will be equal to, then mean of x will be n times p, and the standard, the variance here, the variance will be n times p times q. Not q here is, sometimes we use q, this means like 1 minus p, and standard deviation will be equal to square root of n times p times 1 minus p. So then let's do them here. So it has to be the mean of x. So we expect like 40% of the computers get affected. So for example, this is n times p. What is n? N is like 5 times 0.4. So we expect, this is kind of expected value. So we expect 2 computers to get infected. Now the variance here, the variance of x is equal to n times p times q, which is n times p times 1 minus p, so which will be 1.2, And what is the variance? Okay, let me write the standard deviation, sorry, the standard deviation of x will be just square root of 1.2. So these are the answers for it. Okay, question 5. It is reported that 77% of workers age 16 and over, so we have workers of age 16 and over, drive to work alone. So they drive to work alone. So it says choose 8 workers at random. Find the probability that all drive to work alone. So let's try to understand this. Like we choose one worker, let's say one worker, and we are focusing on whether he drives to work alone or not. So it says 77% of the workers. Okay, this age issue not related to us. Like this is not very important. This is an extra information. So 77% of the workers drive to work alone. So if you choose a worker of age 16 and over, there are two possibilities. Like he drives to work alone, or not. Okay, not drive to work alone. Okay, now this is the situation now. And it says 77% of the workers drive to work alone. So what is the probability of getting, what's the probability of one working, drive to home alone? Drive to work alone, it's like 77, 0.77, it's 77%. And what's the probability of getting not? So it will be not driving to work alone. So this is like 77. So it means like 0.23. So this is the probability of, not driving to work alone. This is the probability of um, driving to work alone. So then you will choose two. You will choose the first worker, the second worker, and then you go up to the 8th worker. And then you have two probabilities here again. Drive to work alone. I will say alone, drive alone or not. Okay, not alone. So you have these possibilities. So you have like 8 trials, and each trial two outcome has two outcome, and each trial are independent. So it means the probability does not change. The probability is fixed for each. Now, this is the situation. Now, we can define the success as driving work alone, or we can drive. We can say success is not to drive work alone. It depends on the question. So it's mostly the questions are asking all drive to work alone. So let's say the success is, let's define success as the work driving alone. Okay, now x, we define x as this now. X is the number of, here you are choosing 8 workers the number of workers workers who drive alone to work. Now, this is the success here. So, what is the success? The probability of driving alone is 0.77. We know it because it says like 77%. So now X will be a binomial distribution. So how many experiments are done? So it means like we are choosing 8 workers here. So each worker means like each trial. So it'll be 8. And the probability of success, which is driving alone, is for each worker we have this possibility, this probability. So it will be the binomial distribution with 8077. So if you understood this part, the rest is easy just to apply the formulas. The main difficulty is most of the time it's this. And in the real life conditions, it might not be easy to see if some random variable is binomial distribution or not. But you mainly have to focus on the outputs. Like if you have two cases, two outputs, and then there's a selection process here, like the choose, if you have this type, and each time it's asking like two things, like one or the other. So it means you have binomial distribution. Anyway, the probability of all the right to work alone. So this means like P, the number of the workers who drive alone, all meet alone, all drive, all means like all workers. So the number of the driving alone should be equal to 8. So it's asking the probability of X equal to 8. So what is this? Oh, you can calculate this one by, the probability. So if you have the binomial distribution, you have to have, this is the formula here, and choose K, and then P to K power, then 1 minus P, n minus K, yeah. So if X is binomial distribution with NP here. Okay, then let's use the formula here. The formula says like H choose 8, okay, and then P is like 0.77, and then this is 8 power, and then 1 minus 0.77 is 0 power. So then you can calculate this one. The probability that exactly 3 drive to work alone, so it means like Px equal to 3. So it will be like 8, 3, 0, 77 to the third power, then 1 minus 0, 77 to 8 minus 3. The probability that more than or equal to 1 drive work alone. So it means the probability, okay, these you calculate, okay. I don't know, maybe in the multiple choice question, the choices might be given to you this way, or you have to calculate the probability that more than one or more than or equal to 1 drive work alone means like more than or equal to 1, probability of 1, more than 1 or equal to. So Px bigger than 1, but in this case we have to write Px equal to 2, and then it goes up to Px equal to 8. And using this formula, we have a hard time to calculate this. Is it possible? Yes, of course it is. It's possible. But let's use this fact here. This will be equal to 1 minus the other probabilities, like the other outcomes. It might be x equal to okay, we are removing what 0 and 1 here. So because yeah, the sum of all probabilities will be equal to 1. So this part means 1 minus the others. So now this will be equal to, then I can calculate now this one. So I can write this is 1 minus the probability of, okay, this 8 choose 0, 0.77 to 0 power times 1 minus 0.77. Okay, I have to erase here. Okay, guys, I will erase this one because you already know the formula here, or you can look it up from the lecture the lecture slides. So 1 minus C, this is 8, 0, and then this will be 0.727. And decade, this is the 0th power. This will be 0.23 to the power. And minus, again, C8, and 8 choose 1, 0.77, the first power, then 0.23, the 7th power. So you have to calculate this. You can see. Now the mean, if we know x is a binomial distribution with np, so then the mean will be equal to n times p, and the mean will be here n, which is 8. Okay, we know this is 8, and then 0.77. So this will be, okay, this is different. So this will be the mean, the variance, the variance formula will be n times p times 1 minus p, and this will be 8 times 0.77 times 0.23. The standard deviation will be square root of the variance. This is clearly the square root of this expression here, 8 times 0.77, then 0.23. Yeah, this is it. Now, let's look at this problem. Question 6. A multi-choice exam is composed of 10 questions. Each question consists of 4 possible answers such that only one is true. Okay, this is exactly what we have in the exams. Like we have 4 possible answers like A, B, C, D. Okay, it's the question. So it says, it has a statement here. We have like 4 choices and we get one of them true. I mean, one of them true, we have to choose. Student chooses randomly. Okay, this is the word, important word. Randomly means like this student doesn't know anything about, he has no idea. Okay, he has no idea about the topic. Okay, so now you're choosing, I mean, this student is choosing them by randomly, so by chance. So like by chance. Says like A, I like A this time, like I like C. Anyway, so he prefers them by chance. Okay, he chooses them by chance, not with a conscious selection. Okay, now so he does this one and find the probability that he has 5 correct answers, and he has 9 correct answers, and he has at least 2 correct answers. Now let's look at this way. Like we have 10 questions, so we can say first question. We have the second question, and it goes like the 10th question. Now, so we are looking at the success. Success means the correct. So in one, when we answer the first question, we have 2 possibilities, right? We got the correct answer. Get the correct or no. Okay. So here it means like your selection is correct or incorrect. or you can say here, your answer is now in the first question is correct or incorrect. Now we have also these cases for each question. We choose either correct one or incorrect ones. So we have two possibles. So two outcomes for each question. So it's like each trial. These are like trials here. And these are the trials, like the first trial, second trial, and each trial has two outcomes. Two outcomes. And each trial are independent of each other. Whether we choose the correct or incorrect in the first question does not affect the other one. And okay, this looks like a binomial distribution here. Binomial distribution it's going on here. Okay, now what is the probability of correct? So yeah, for each question. So if it is choosing randomly, it's correct 1 out of 4 choices, so it will be 1/4. So this has to be the incorrect will be 3/4. So one will be correct one, the others will be incorrect. So the probability of correct is 1/4. The probability of choosing incorrect in one question is 3/4, and it's the same thing for the others. So it's like tossing coin, but this time the probabilities are different. Okay, we have again two outcomes, but we have different probabilities. Now we have a binomial distribution, and let's say this is success is okay. This is a binomial distribution here first. And our success here is getting the correct answer. What's the probability of getting to answering a question correctly? So answering question correctly. Okay. Now this what is the probability of this? It's 1/4. The probability of success is the probability of getting correct in one question is correct is 1/4. Now how many questions we have? So how many trials we have? We have 10 questions. So and the number of trials is number of questions. It's 10. Okay. Now the x is the number of success. Number of success. So number of correct answers. So the number of the questions answered correctly, let's say. Okay. Now then the x will be the binomial distribution, like n. N is like 10. Choose 10, and the probability of the success, which is choosing correct in one question, is like 1/4. So we have a binomial distribution, and then x is the number of correct questions. So number of the questions that are answered correctly. So here it's asking what is the probability of choosing 5 correct answers. Exactly 5 means px equal to 5. So this will be px equal to 5. And this will be, okay, here, if you have this one like this, pxk means probability of having k successes in n trials is like in 10 trials will be like 10 choose. Okay. And then this will be 1/4 to the k power times 1 minus 1 over 3, 4 to the 10 minus k pi. I mean 10 minus k power. Okay, then this will be 10, choose 5, and then 1 over 4 to the fifth power, then 1 minus 1 over 4 to 10 minus 5. Then this will be equal to, this will be equal to the probability of this. So you can do it with the calculator. Now he has at most 9 correct answers, so it means Px is at most 9, means like it will be less than or equal to 9. This means Px equal to 0 plus, no correct answer up to 9. Okay, this will take a big time, so for this reason we have I will use a shortcut. The shortcut is, it will be equal to 1 minus the other cases, so it will be 1 minus the probability of the other cases. The other cases like 0, 1, 2, 3, 9, but it says at most 9, so what is the opposite of it? It means all of them, so it will be Px equal to 10. So this excluding, this means like I'm excluding the this outcome here, x equal to 10. So it will be 1 minus, what is the probability of this? This will be like C 10 to 10. So it means n choose 10 choose 10, 1 over 4 to the 10th power, and then times 1 minus 1 over 4 to the 10 minus 10, which is 0. Okay, so he has at least 2 answers, correct answers. So it means the probability of these 2 correct answers, that means like he has not at most, sorry, it will be at least, so it means it will be bigger than or equal to 2. So in this case it will be equal to Px equal to 1, 0, no, not 0, sorry, 2 plus up to 10. So okay, this will make a big that will take a big time. If I use this formula here, it will take a big time for each one, but I can say this one is equal to 1 minus the others, so it will be like Px equal to 0 minus Px equal to 1, and that's it. Now the rest is there, so I will calculate these probabilities by using the binomial formula, and they will be 1 minus the probability of having, like, what's the probability here? So I will use this rule, and that's 10 choose 0 times 1 over 4 to the 0th power times, I will say this one 3 over 4 now. Okay, 3 over 4 to the 10th power, 10 minus 0, minus 10 choose 1, 1 over 4 to the first power, and 3 over 4 to the 10 minus 1. So this will be the answer here. So you can use a calculator to do it, or I mean, if you want to do it by hand, yes. I think no, it's with the hand it will take like a 10th power. We cannot calculate it. Either it will be given this way in the multiple choice, or you have to use a calculator to find it. I think that's it now.